Hello viewers, in today's lesson we will be discussing about the power rule of differential calculus, and as we all know that we've discussed about the first principle of differentiation in the previous video. So if you are yet to watch the previous video, make sure you refer to that to have a better understanding on the first principle of differential calculus. So without wasting much of our time, let's jump into what we have today. The power rule of differential calculus says that if we are having a function f of x, which is also giving us a function y, let's say function f of x is ax raised to power n. It is called a function f of x because it is in terms of x. If it is a function f of a, it will be in terms of a. If it is a function f of b, it will be in terms of b. If it is a function f of z, it will be in terms of z. So it says the first derivative of f of x, which is f prime of x, which is also what? The y dx, is giving us n multiplied by ax raised to power n multiplied by ax raised to power n, then you subtract 1 from it, minus 1. So that is the power rule of differential calculus. So without wasting much of our time, let's solve one example on it. Let's say we're having a function y equals 3x squared plus 2 over x plus 4x raised to power 3. Then this can be conveniently written as y equals to 3x squared plus 2 x raised to power minus 1, since if this x moves up, then it carries minus 1, plus 4x raised to power 3. Then we apply our power rule to find the first derivative. The y dx will equal to 2 multiplied by 3, and that gives us 6x. Then subtract 1 from 2, and that's 1, and that automatically becomes 6x. Plus minus 1 multiplied by 2x raised to power minus 1, and that gives us minus 2x minus 1, and that gives us minus 2. That gives us minus 2x raised to power minus 2 plus 3 multiplied by 4, and that gives us 12. You subtract 1 from 3, you are left with 2. Then it can be finally written as 6x minus 2 over, if this x returns back to the denominator, over x squared plus 12x squared, and that's the final answer to that. Let's solve one more example on, and that, let's say we are having y to be equal to 2x raised to power 4 plus 4x raised to power 3. Then the y dx will be giving us 4 multiplied by 2x raised to power 4, and that's 8x. And you can subtract 1 from 4, and that's 3. Then that becomes 8x raised to power 3 plus 3 multiplied by 4, and that's 12, plus 12x, and subtract 1 from 3, and that's 2. And the final answer is 8x raised to power 3 plus 12x squared. Let's solve one more example. Let's say we have y to be equal to 8x plus cos x. Then the y dx will giving us, here we have 1 multiplied by 8, and that's 8. Then 1 minus 1, that's 0, and then 3 raised to power 0 is 1, then automatically becomes 8. Then cos x is a standard derivative, and the first derivative of cos x is what? Minus sin x. Then this automatically becomes minus sin x. Then let's say we have, let's solve one more. Let's say we have y to be equals to 3x squared plus 1. Then the y dx becomes 2 multiplied by 3, and that's 6. That's 6. Then you subtract 1 from 2, that's 1. This becomes 6x automatically. And we all know that the first derivative of a constant is always 0. It's always 0. And why is it 0? Because this is something like 1 x raised to power 0. Since x raised to power 0 is 1, then if you now multiply 0 by everything here, it makes everything to be automatically 0. This makes everything to be automatically 0. So the final answer of this is 6x. Let's solve one more. Let's say we have y to be equals to 4x raised to power 5 plus exponential x plus cos x plus cos x. Then the y, the x, will be giving us 5 multiplied by 4, and that's 20. Then you subtract 1 from 5, and that gives us 20x raised to power 4. Exponential x is also a standard derivative, which the answer is also exponential x plus exponential x plus exponential x. Then as we all know from here that the derivative of cos x is minus sine x minus sine x minus sine x, and that's the answer to that. Let's solve one more, which is the last example of this lesson. Let's say we have y will be equal to 2s cubed plus sine x. Then the y, the x, will be giving us 3 multiplied by 2s cubed, and that's 6x. Then subtract 1 from 3, and that's 2. Plus, you all know that sine x is also a standard derivative, and the first derivative of sine x is what? Is cos x. It's cos x. And that's that about that. And I believe that with these sub examples, these good 6 examples, you should have understood the power rule of differential calculus. In the subsequent video, we'll be talking about the quotient rule of differentiation, the product rule of differentiation, the chain rule of differentiation, and implicit function differentiation. So if you are yet to subscribe to my channel, kindly make sure you subscribe to my channel and make sure you turn on the notification bar so that you will get notified when we upload new videos. Thank you.